All right. Hey, everybody. How y'all doing? Sweet. All right. Well, I'm super pumped to be giving this talk today. I'm going to be talking about the peer-to-peer web. And this is mainly talking about a project that I've been working on, which I'll get to that in a second. So the name of my company is Blue Link Labs. I co-founded it with Tara Vansel, and we're located in Austin, Texas. It's just the two of us. And the name of our project is the Beaker browser. And it's an experimental peer-to-peer web browser built on top of Electron. That's actually kind of an old screenshot right there. But that's what we're going to be talking about tonight. So let's start by talking a little bit about the basics of the web, how the web works, especially way back in version 1 of the web. At its core, the web is really a way to exchange documents. It's a document sharing network. And the way that you would publish a document is by uploading it up to a website, or excuse me, to a server. And that server would give you a URL, and you would give that URL out to whoever wants to download it, and it's exchanged by the server. So that's how you do publishing in the original version of the web. Now, of course, the big idea with the web was that you'd be able to link between these documents with hypertext, right? That was the big idea, and the server was sort of an incidental aspect of the implementation. It was an implementation detail. It was really much more about the links. But over time, as the web got more popular, people wanted to have more dynamic behaviors in their websites. They wanted to be able to do things like edit the content of a web page inline inside the browser, like with Wikipedia, or you wanted to be able to post status updates, like with Facebook. And so over time, we began to put some code, some custom application code into the server so that we could do things like that. And to go along with it, we would add databases, right? And so over time, we got away from the original idea of these servers being relatively dumb and all about just the links and the documents, and much more into an application platform that was built on top of the web. And that eventually brought us to the Web 2.0 and the model that we call the thick server model. Right? And that's the world where you have code and your database all living up on the server. And that's really where the application runs. And then all the users' devices are what we call thin clients. They just talk to the server to get their work done. Okay, so all that code is living up in the server, and that actually works really well. That's how we do a lot of applications these days. There's a lot of reasons for that. First of all, the web is a really great platform because it's available on almost every device. So you could write the application once and then deploy it to a lot of different devices, and that is a lot faster than having to write it for Apple and also Windows and all the different mobile devices. There's also a whole lot of advantages that you get out of the cloud that we all appreciate every day, both for users and for the developers. Of course, the cloud is always on, right? Your data is always available, so you can switch devices and immediately pick up where you left off, and that's a big deal. Back in the day, people had to sync devices all the time, and that's not a lot of fun. It's centrally managed for you. If you're a developer, it's great because you can deploy and update once, and everybody gets the same version all at once, right? You can handle the business model, is a really nice model with SaaS, right? So we've been doing this a lot to the point where it's kind of like, well, let's just do everything this way. You always use the cloud, right? Why wouldn't you? And you could call that a monoculture, right? Everybody's doing it the same way, which is client-server. And we keep on sticking more databases and bigger services up there. And it has gotten to the point that even if you're doing something which is conceptually a peer-to-peer exchange, like sending a file from one computer to another, well, how are you going to do that? You're going to use something like Dropbox, right? You're going to ping it through the cloud. So that's kind of where we are now. So what's wrong with that, right? It works. The cloud works. Why fight that? It can't be this. It can't just be, oh, I don't like corporations, or I'm not really a fan of Facebook. We actually have to have some really concrete ideas of like, what are we trying to get out of this? Why move away from the cloud-based architecture? And well, let's go through a couple of them. The first one is that there's a lack of privacy in the cloud-based model. For whatever reason, there has never been a good way to exchange a file or a message or a document on the web without having to expose it to a third party. So this has led to a couple of different problems. The first is if you're trying to exchange sensitive information like medical records or legal documents, things like that, you're exposing your users to some risk. Because there are warehouses, data centers where this stuff is potentially sitting in plain text. So in terms of our obligation to our users to make sure that we're really securing their data, we are to some degree failing that obligation. Okay? On top of that, there's maybe a broader problem, which is that it's kind of creepy that all these services have a lot of personal information that they really shouldn't have. And that's going to erode a lot of trust in our industry over time. So it's something we should take seriously. The next problem is the lack of user modifiability of these web services. So show of hands, who here has had a pull request merged into Facebook today? Nobody, right? This has a couple of different really impacts on the world. The first is that it has a chilling effect on innovation. People are not able to solve their own needs whenever they're using somebody else's web service like this. And this became really hotly politicized during the last election cycle, as we began to deal with the ideas of what kind of news is valid. And Facebook was put in a position where they had to start to make a choice about whether or not they're going to try to cut out what they consider to be fake news. The fact that it's Facebook's choice and not the user's choice to decide how our information systems work means that there's one company making this decision for everybody. But we're digitizing our lives, right? This is where online society is occurring, so shouldn't the users be in control of this? Shouldn't this be a much more sort of community-driven experience? Connected to this is the fact that we don't actually own our data. So even if I was able to get a copy of all of Facebook's source code and deploy it onto my own server somewhere, I wouldn't actually be able to connect into the Facebook's network. Everything that they do runs on their architecture, so I couldn't connect to my friends and send them messages or follow new people because I'd be running on servers that are somewhere else, not on the Facebook infrastructure. So this also slows down the ability for us to create our own custom applications on the web. So when somebody asks me for what's the motivation for a peer-to-peer web browser, usually what I tell them is it's actually pretty simple. Services are kind of creepy, and people want to own their networks. Now, in a slightly more dry kind of engineering view, what you could see what's happened in the web is that we have an architectural deficiency. We've gotten really, really good at handling client-server. Like, we put a lot of effort into that. It works really nicely. But the web is a platform for running networked applications. And we haven't put as much time into alternative networking models. The peer-to-peer networking model is really pretty anemic. WebRTC doesn't really make a significant change in how we build applications. It has some fairly narrow use cases. What we would really like to have, or what I would like to see out of the web, is to have flexibility on this. That not only can you do client-server, but you can also use peer-to-peer or a hybrid of the two, based on what you need out of your application. So let's talk about what we've been doing at the Beaker project. Broadly speaking, what we're doing is taking peer-to-peer networking and seeing what we could do with the web after we introduce a really solid core of peer-to-peer to the web. Not getting rid of client-server, but adding peer-to-peer to it. Now, there's actually a lot of different peer-to-peer systems. We're not talking about blockchains in this project, and we're not talking about WebRTC. What we're actually talking about is a peer-to-peer file distribution network that's a lot like BitTorrent. The name of the protocol we use is DAT, and I'm not going to talk a whole lot about that tonight, but just keep that in mind because you'll see it around at different points in the talk. But again, it's very much like BitTorrent, and the way we use it is as a drop-in replacement for HTTPS. So we use DAT to exchange websites and web applications, and also as a way to exchange user data from one user to another. Now, because it's a BitTorrent variant, it works a lot like you might expect if you've ever used BitTorrent. Whenever you visit a website, you will, for a period, enter into the peer-to-peer swarm and contribute bandwidth back. So you will briefly rehost those files, and you can actually choose to continue to do that if you like the site and you want to contribute more bandwidth to it. And it's also possible for any device to become a server at any time. So a laptop or a mobile device could begin to publish a site and share that on the network in a completely ad hoc fashion. So going back to our diagram about how publishing a document would work on this web, there's no longer a server component. I can create a new website, and if somebody wants to access it, they're just going to download it directly from my computer. Now, if somebody else accesses this, you can probably predict what's going to happen when we add a third downloader, because you understand what BitTorrent does. right? As somebody else asks for it, rather than just the one server that's my computer, we now have two servers, right? Because the person that downloaded it from me has contributed bandwidth back to the network and is rehosting it as well. And this effect compounds, so you get more and more computers as an asset becomes more and more popular. And this is what we call a peer-to-peer swarm. And the swarm is sort of like a distributed server. It's one way to think of it. Another way to think of it is like a peer-to-peer CDN. Really, really good at distributing files that are static. The swarm has some really interesting implications for how you build an application. The first thing that's really interesting is it dramatically reduces the cost of bandwidth for somebody that's publishing content on the web. Because the network automatically scales up, the person that publishes the content does not have to shoulder the cost of the bandwidth. And outbound bandwidth is by far one of the most expensive parts of web hosting. If you were to have a server at home that runs traditional HTTPS, for instance, and you had a video go viral, your home computer would probably, first of all, get crushed by the load, so it might not even be able to handle past 100,000 people, right? But then you'd also have to pay for all that outbound bandwidth, and most people can't afford that. So with a peer-to-peer swarm, it actually becomes possible for independent publishing to occur and for that to actually get very popular, right? Whatever asset you've published. The other thing it does that's really interesting is it makes it very, very cheap to create new websites. Because in this cryptographic peer-to-peer network, every website is addressed by a public key, okay, instead of an IP address. And so if you want to create a new website, you simply have to allocate a new key pair, which is incredibly cheap to do. And this changes a lot of the model for how you create a website on the peer-to-peer web. Because rather than having to use a database, as you traditionally do, to store records somewhere, instead what you can do is simply create a new website and write JSON files into the site. And you can use that as a stand-in replacement for the traditional database model. And off of that, you can begin to create applications which are entirely serverless, which exist in a purely peer-to-peer networking stack. It's kind of an interesting, almost Web 1.0, all websites kind of thing, or maybe a little bit like the semantic web. So let's talk about what it's like to build applications on the stack. At its core, again, it's a files-based data model. Again, we're talking about the DAP protocol is what we've chosen to use. And this is a view that's actually available inside the browser. You'll see it a little bit later when I demo. And you can see a listing of files in a website, which is actually kind of a unique feature. You can see everything that's there inside of the site. That API has a number of capabilities that are exposed as a web API to applications. You can list files in a folder. You can read and write files. You can actually see a change history, sort of like a git log for a website. And you can also listen for changes, which ends up being extremely important for having a good reactive application. At the moment, the way that the permission model works is when you create a website, you become the owner of it, and you are the only one that's allowed to write to it. Everybody else is read-only. In the future, we're going to make it possible, it's actively being worked on to allow multiple authors so that you can authorize somebody else to make changes to a website. But at the moment, it's only the original author can change the site. So to explain how application development works, especially related to the data model, let's go through a hypothetical example. Let's say we wanted to make a Twitter clone. Now, the traditional client-server model, what you would do is you would set up a server up in the cloud that's going to run the application. And when I want to create a profile on your Twitter clone, I would talk to your server and say, hey, please make a profile for me. And it's going to allocate a record inside of its database somewhere saying, this is Paul Frazee. And anybody that contacts the server can get that information. Right? That's the traditional model. Notice that in that model, you have the database inside of the cloud with a server, as well as the application code. In the peer-to-peer model, the first thing you should notice is that the code has moved down into the client. Instead of being thick client and thin server, it's actually thick client. And the network is now acting a little bit like a database for us. So rather than talking to a server, whenever I get to this peer-to-peer application, if I want to create a user account, what it's going to do is create a new website for me. It's going to create a new peer-to-peer website. And inside that website, it's going to write JSON files that includes my profile information, like my name and my bio and things like that. It's going to include all my tweets and my likes and who I follow and all of that information, right? And then we're going to use the peer-to-peer network to distribute that data. So here's that visualized graphically. We have here our Twitter clone right here, and that's one peer-to-peer site. And then here is my user profile site that it's writing all my data into, okay? And this is all occurring completely locally on my device. This is inside my device. So in fact, we could actually do this without being connected to the internet at all. We could do all these writes, and then once we get onto the internet, we could begin to host it up to the rest of the network. So there's an advantage that the network could drop and things would continue to work as you would expect. So here's what that profile.json might look like. It's very straightforward. You got your name, you got your bio, what my picture is, who I'm following. Now let's say that I wanted to get a listing of all the people that I follow as well as my profile, right? So I want to list the names and bios and their pictures. So how would we do that in this model? So what we're going to do is that everybody that's on this network has their own website representing their user account. And on each of those websites, there's a profile.json. So I'm going to go to each of these sites, access them on the peer-to-peer network, and I'm going to download from each of them their profile.json. I've already got mine up on my computer, but I'll grab Tara's, and I'll grab Alice's and Bob's, get that profile.json from each of them, and I'll just aggregate them into a table. And that table might be in memory, or I might store it on disk so that I can read it later, so it's nice and cached for us. And we just stick in each of the different attributes we want to render. And then what's nice about this table view is that it's very easy to begin to query it. So we could start to filter it based on whether or not they have all of their attributes set. So if somebody doesn't have an avatar, maybe I don't want to render it, right? And so you can start to write queries against this in a traditional database modeling. And that model, it turns out, has worked well enough that we've codified it into a module, which we call ingest.db. That's not a typo, that's a pun. Ingest, like you're eating the records and then computing out a table view. So what we have over here are our sources of truth. These are the peer-to-peer websites, okay? And these are where all the records are written definitively and then distributed. From there, ingest will scan the file listing of each of these archives and look for files that are relevant to it. So perhaps for our tweets, we might use the posts folder, and we'll look for any JSON inside the post folder, and it looks like there are 2 JSON files. So then we'll take those and stick them into a table, and we actually write this table into indexed.db, right? Which is nice because it means that ingest can actually run inside of userland. Applications import this from Node to use. And then this table, we have a bunch of different queries written, built on top of the indexed.db, so you can do things like give me within the recent 5 minutes posts have been made, or order them by the name of the author, what have you, right? The kind of things that you would expect when you're writing an application. If you were to then want to create another post, another tweet, what you would do is you'd go back to the archive and you'd write another JSON file, and that puts it in the source of truth, which is your website, and then that's going to get ingested back into our table view for querying. So this is the data model that we're working with primarily, the peer-to-peer web database model. It's files at its core. It's a file system. We distribute the records as JSON files, and then we aggregate those records into queryable tables. Now there's a lot of different concerns that we're still working on, and I have limited time, so I'm going to jump straight to this question. Where does this work really well? And I think this is worth talking about so that you can get an idea in your head about what this technology actually is. File sharing, by the way, asterisk, because we think this is what things will work well for. File sharing is a pretty straightforward use case of this. At its core, the peer-to-peer network is a file sharing network. We think that social applications will work pretty well because social applications are, generally speaking, peer-to-peer exchanges. So that's a pretty natural data model. Office and productivity are 2 areas that are actually really great for this model. Not only do they usually involve small groups of people exchanging files, but you also have a relatively high privacy barrier because you're trying to protect intellectual property. So using the peer-to-peer model, you can avoid uploading data to the cloud entirely. Your users can simply keep the information on the Wi-Fi. And if you do have to use the cloud, we're pretty sure we're going to be able to put end-to-end encryption into the stack relatively soon so that we can give a very solid guarantee that you're only getting that data sent to the people that you want to have it. Finally, publishing is a really great use case for this, again, because of the bandwidth saving. The network helps you shoulder the cost of the bandwidth, and as a result, you can publish independently without having to rely on somebody like YouTube to shoulder the cost of bandwidth for you. Now, where will it not work quite as well? We expect that anytime you have to deal with a whole lot of data, this model won't work quite as well. For instance, Reddit has to deal with a whole lot of comments and upvotes and aggregating those into a nice view. That's probably more data that's going to work than will work nicely. So something that involves aggregation, not as good. Search engines, so far there's never been a really good peer-to-peer search engine. Arguably, there's only been one really good search engine so far, so that's a questionable area to go after. Also, if you have a single piece of information that you want a lot of people to coordinate around, like with Wikipedia, you probably wouldn't want to do that with the peer-to-peer model. It's probably better to do client-server. Now, I say all this also saying probably because you never know what people will come up with. But if somebody asked me, hey, what should I do with this technology? I would say, well, don't make Wikipedia. That's probably not the right use case for this yet. So let's get into a demo of this. This right here is the Beaker browser. It's an unreleased version. We're making actually a lot of changes in this, so y'all are the first people to see this version. Version 08. Works a lot like you'd expect out of a web browser. You can visit sites and open up lots of tabs and zoom in and out. What you would expect. What's that?
Don't read the comments.
Don't read the comments. Let's get out of here. So let's jump over to something a little more interesting. This is the website for the Beaker browser. And if you look up here, a little button appeared that you don't normally see. And this is letting us know that there's a peer-to-peer version of the site. I'm sure some people are wondering how that button knows to exist, and you can ask me later. But for now, just know it. We can do it. And when I click this, what you want to watch is the protocol up in the top left, because that's the only thing that's really going to change. So let's go ahead and click it. And there we go. So now we're on the peer-to-peer version of this website. And we changed over from HTTPS to DAT. And like I said before, it really is a drop-in replacement for HTTPS. The experience is basically the same at its core. We can click around and hit links. There's embedded images. It's very much the web. Where it begins to get a little different is if you look up here, you can see, well, not a lot of people on the network right now, but at least one other person is sharing this with me. And so you can kind of get an idea of how popular a site might be at the moment based on that count up in the corner. There's some other neat features that are specific to the peer-to-peer stuff. For instance, a rehosting tool. So if you find a site that you think is pretty neat, or maybe your friend made it and you want to help out, you can jump up to this thing and say, don't just download the files that I access, download the whole thing, and then let's rehost it on the network so that we can make sure their site stays online. Right? So it's kind of an altruistic social sharing kind of thing, or bandwidth sharing. And you can use this slider to say, don't want to rehost it, or you can say rehost it forever. Or maybe you just want to do a couple days, a couple weeks, something like that, and you can just set it like that, and that'll just start a timer. And then after 7 days, it'll stop rehosting and automatically clean it up off your device. Well, this is my site, so I'm going to keep going. Some other kind of cool features that we have that are specific to peer-to-peer. First of all, it's possible, because we can list all the assets and access them in one big bundle, we can actually download them as a zip. It's kind of a nice way to export a web application or a site. We also have the ability to fork a site. This is forking almost like in the Git sense, where we take all the assets that are inside of a site and then just mint a new site and copy them all over. And then with this new copy, my computer will be able to edit it. So I could fork this website and change it to have my new browser's branding and steal everything from us. And then, of course, we have a file viewer. So let's jump into that. This is probably the roughest interface. It's like I said, this is a lot of beta work that's not done, so a little bit buggy. But what we're looking at is a listing of the files. So I can click around and see what all is inside of this website and jump into one. Let's jump into the FAQ here. Right? It's a neat little feature. You can see all those files. So let's move on to something that's Well, these are all pretty unique features, but let's get into something really cool. Let's get into the fact that you can just create a new website right from the browser. Okay, so maybe a little bit of an underwhelming thing to see there, but that's our site. It creates automatically a single file for us, and that's the dat.json file. This is sort of a metadata file. Now, if you look at the top, you see a URL that is extremely long. That is a public key. It's encoded in hex, so it's 64 characters long, which makes it a 32-byte key. That's the same URL that we have right here, but Beaker is nice enough to collapse it because nobody really wants to have to look at that whole thing. That is basically the equivalent of an IP address. But in the peer-to-peer network, it's a cryptographic public key. And like you saw before, we have a way of doing DNS. Like with the DAT site, we have dat.beakerbrowser.com. So there's a way to make it look nice for users as well. But whenever you create a site, it's going to mint this. So let's go ahead and add a file. Cool. So now if I were to take this URL and copy it and give it to somebody, they'd be able to download this file directly off of my computer, right? So this is a website. If I go to the top level, we'll get a listing of the files, which is kind of what you would expect if you had a website with like Apache and you didn't have an index.html, right? So just to kind of finally wrap it all up, why don't we go ahead and add an index.html that I prepared earlier. And there we go. So it should be pretty clear this is very much like a normal website, but just taken right over to the peer-to-peer world. If we click on View Source, we can see this code works exactly the way you expect, with an H1 and an image referencing the image tag referencing the image. So that sets the foundation, right, of how websites and web applications are distributed. So let's show just a couple of other demos that show a little bit about the data model. To do that, let's open up an application which has maybe a 20% chance of crashing the browser. So hold your breath. This is a code editor that we wrote. We actually originally wrote this thinking that we were going to make it a part of the browser. So we spent a month really, really working hard on this. And then it turns out that we decided it was a bad idea, so we took it out. But we were lucky that it was actually possible to port it entirely into user land as a web application. So it's now a peer-to-peer web app. Still needs a little bit of work. But basically, we're using the code editor from VS Code called Monaco. And it makes a nice kind of IDE-like experience. And we can use this to not only view, but also edit other websites. So here's where the interface really shines. Not really. OK, didn't crash. We made it. So here's the site that I was just showing us earlier, right? And so I can just make a change real quick. Here it is, right? Let's close out some of these tabs. I'll save that, and it's going to ask permission because it's about to change another side on my computer. So of course you want it to ask permission before it does that. So I'll allow the change and refresh it over here. There you go. All right. So it's almost like we have, well, it actually is like we have a file system. It's built into the browser. It's its own kind of sandbox file system. And that's what we're looking at here. We're seeing all these different sites over on the left, and these are sites that either I created or that somebody else created and I downloaded and decided to save. And we can just browse through each of these sites almost like we're looking at a files finder. And that's the interface that we're using here. One other thing that's kind of neat, let me see if I can make this work. This is another possible failure, but the way that this protocol works, remember how I said you can watch for changes to a file off of the API. So part of what we've done to take advantage of that is turned on, or added rather, an ability to turn on live reloading. So that the browser itself will watch for changes to a site, and then if it sees a change, it'll go ahead and refresh it for us. So I've turned on live reloading on our site, and that's a little lightning bolt there that indicates that it's on. So I'll go back to our editor and express a little confusion here. And you see that reloading automatically for us. That's kind of a neat little feature.
Nice.
Oh, no, that's not what you want. Sorry about that. That might hurt the video quality later, but we'll see what we can do. We good? All right. What else have I got? All right. This is a neat little application, the WYSIWYG. So this is a wiki that is self-modifying. The way the API is set up right now, it's actually possible for an application to modify itself. Now, this may be a really bad idea in the long run, but it was kind of one of those things where it's like, well, this is kind of neat, and it might be a nice way to make something like a wiki, right? So to demonstrate this, I'm going to fork it. And this is a built-in API that is sort of a convenience. It's going to, like I said before, make a new website, so js.la wiki. Let's keep that the same and create a fork. All right, so that happens pretty fast. Change the URL is really the only way you would know that something had happened there. But now we can edit it, and it opens up our WYSIWYG right in there. And why don't we center it and give it some fancy styles. Hit save. Okay, and if I refresh the page, that content's going to stay. Now, if I view the source, what we'll see, unfortunately there's no highlighting here, but if you look right here, there's that content that I just set. So it just used the files API to change its own index.html. Again, not really sure if that's going to stick around, or maybe we'll need to add some protections to try to avoid some weirdness, but for now it's kind of a fun feature that we have. All right, I got to cheat. Right. One other thing I want to show is some features that we've begun to add to the browser. So we've been working on this for about a year, and had a lot of the same capabilities that I've shown for a while. But one of the overriding responses we've gotten is that the experience feels a little bit unstructured. People say, okay, these are neat features that you've put into this browser, but where do I start? What am I supposed to do with this thing? And so one of the things we started to explore recently is we have this peer-to-peer publishing network. And normally you don't want to bundle a service into a browser, right? That's a kind of a lock-in that you're not supposed to do. But if you're able to use a peer-to-peer publishing network, we can start to add networking features into the browser without creating some kind of weird lock-in. In the long run, we think we can farm this out into user land, but for the moment, what we've done is added the ability, for instance, to share bookmarks socially. So, in fact, why don't I start by going to another page? I always start with DuckDuckGo. No, I got it. Of course. And I can hit the bookmark button, and then right here there's a little sharing decision I can make, and I can make it public and save it. And then there it is right there, publicly shared. And so if somebody follows my account, I have a little account that's built into this thing. Excuse me. And if somebody's following me, they'll see my face right here in their friends, and they can click on that and see this is what Tara has shared with me. And it's a little website that's dedicated to our cat, Sasha. So that's kind of started to kick us off on a couple of ideas of how we can start to really exploit the peer-to-peer features in a way that maybe shows people what you can do with it and gets them kicked off into the network. But this is actually kind of important because one of the big questions you have in the peer-to-peer network is if you're not, if your site's not popular, then it's not going to be online, right? If you were to create a site and then turn your laptop off, well, you just got rid of the only server. So if you don't have like 5 people seeding it for you, then it may go down. And so one of the features that we're starting to look at based on this is, well, we can have these built-in profiles here, right? And you can start to follow people. And we also have this file system right here. So let's say we just made this js.la wiki. Maybe I could publish that on my profile. And then anybody that follows me, maybe they'll say, anytime Paul publishes something, rehost it for a week automatically. So we can start to socially give each other the bandwidth that we need to keep our assets online. And that's what we're going to start to do where, just like with the bookmarks, we're going to look into having the people that we follow show up in this library view here, this file system view, and see the sites that they've published. So there's a kind of a file sharing core inside the browser as well. Now, just to bring this all full circle, here's my profile. I got my bio and my avatar and my picture and my name. If we go into the file system and we look, right here is my profile site. And just like I was talking about before, there's that profile.json, right? This is the exact design I was talking about before with name and bio, avatar, the people that I'm following. There's Tara Vansel's website right there. And then let's go to bookmarks, and there's that bookmark I shared. So again, it's really pretty straightforward. It's just files, JSON files that you're sharing on these peer-to-peer websites. So let's do just a couple more slides to wrap this up. So here's my highly biased timeline of the web, talking about the past and also where we kind of think this could go if people like what we're talking about. This is biased, but I would say in the 90s, you really had a kind of an academic or hobbyist-driven web. It was still a little bit crummy, but it was exciting. And as a result, it was somewhat esoteric. But we still had some pretty big things happening at the time. Shopping was beginning to happen with Amazon. And we started to have the search engine show up. In the 2000s, the web started to get a little less crummy. You started to be able to have more interesting applications. And on top of that, it started to commercialize really heavily. So from 2000 to 2008 is what I would call the startup era of the web. There was a lot of innovation, and it was a lot of just seeing like what amazing thing is going to show up next. I forget this all the time, but before MapQuest, that was huge. Like when MapQuest happened, and then Google Maps, right? It was amazing. 2008 on, things kind of solidified a little bit because we really got some winners. Facebook, Amazon, and Google sort of won the web. And so from 2008 to the present, I would say what the zone we're in is those are the sites you use, and they kind of set the agenda not only for how people interact on the web, but also for how the web progresses forward in terms of technology decisions. By and large, Google has been relatively a strong steward of the web, but I would consider the corporations to be the predominant force inside of what the web is now and what we do on it. So where do we go from here? What's next? Whether by the kind of technology that we're talking about with the Beaker browser, or perhaps there's something in the blockchain world, what I think we're going to be able to do is move away from this corporate-driven web and into a completely consumer-driven web, where the applications that we use are written and deployed by users. And that can get us to a point where we're able to, again, solve our own needs and have something which perhaps feels a little more authentic and a little more community-driven, as opposed to something that is designed to make advertisers happy and corporations happy. So thank you all very much for coming and listening to my talk.
I don't know if you guys ever played around with peer-to-peer technology. It's the coolest thing ever when it works.
Mm-hmm.
No, it really is. All right, I think we have enough time for one or two questions. So does anybody have any questions? Right here in front. Don, throw it over here.
So I had a question where, let's say a server-side database, one of the big features is accuracy, data accuracy.
Mm-hmm.
In your JSON files structure, how do you convey to other users that the data is accurate as possible? Let's say if I update a profile, my one profile right now, and there's about, say, 10 people following my JSON file, how soon does those JSON files get updated?
That's a good question that touches on a lot of different things. I think maybe the core question that you're asking is how do you know that the new profile.json came from me? The answer to that is that the peer-to-peer network is a cryptographic network. Every website is addressed by a public key, and every update to the website is signed by the matching private key. On top of that, the files are distributed. Well, how deep do I want to go into this? There is a log of changes to every website. It's kind of like a git log. And inside of it, it references each file by a hash. And you use that to verify the integrity of the files as they come over. And then you verify the log that you get by a signature on each of the updates. So you're verifying those updates against the public key that you've chosen to trust prior to then. Does that make sense?
It's more like it's kind of close to IPFS.
It's actually very similar to IPFS. When we were working on Beaker, it was a big question. Do we use IPFS or DAT? And we landed on DAT.
All right, next question.
So a question. Let's say, hypothetically, I'm Beaker. Okay. And I have like 30 million followers on Twitter.
Yeah.
If I send out a tweet, does that mean that 30 million network requests are happening to download tweets that are made on my server?
Yeah, at least. That's pretty much the same situation as with client server too, though, right?
Fair point, yeah.
Yeah. I will take that opportunity to point out, though, that one of the neat things about the Swarm is that it does a very lightweight polling over the network via UDP to check for updates. And then, as a result, you actually you should end up with fewer requests overall when you visit a website, because you can actually do cache invalidation by this polling. So if I go from index.html to about.html and back to index.html, I won't have to send extra requests because I'll know nobody told me, hey, this got updated, right? So there's actually going to be bandwidth saving overall in this design.